Hello everyone. In the first lecture, I mentioned three classic and most frequently used definition of fractional order derivative. GL is one of them. They derived this definition in 1867 and 1868. GL formulated the fractional order derivative by the fundamental definition of the derivative which is given by this u prime t, the first order derivative, which is equal to limit h goes to 0 t ut plus h minus ut divided by h. So this is the definition, fundamental definition of first order derivative. Then the nth order derivative is given by this formula, where this cmk, which is the combination which is given by this formula, and we can also use the notation for cmk with nk for simplicity. Now the ZL definition of fractional order derivative is a generalization of this nth order derivative by replacing n by this alpha, where alpha is a real number, it could be a fraction, and the summation, the finite sum, is replaced by infinite sum, and this factorial is replaced by the gamma function, what we talked about that in the first lecture. Now we find the fractional order derivative or alpha order derivative of exponential function, exponential of bt, where b is a constant, using this ZL definition. So the alpha order derivative of this exponential function, exponential of bt, which is equal to, we simply flag this formula, limit h tends to 0, 1 over h to the alpha, summation over k, 0 to infinity, minus 1 raised to the power alpha. C alpha k, we can also use this notation, alpha k, and exponential of bt, this t we replace by this, t times alpha minus k times h. Now we can take this exponential of bt outside the limit, exponential of bt times limit h goes to 0, 1 over h to the alpha, summation over k, 0 to infinity, minus 1 to the alpha, alpha k, and here we left with exponential of b times alpha minus k times h. So we can write bh times alpha minus k, we can write as exponent. So if we look at this summation, this term we can replace by a power function. The power function is exponential of bh, this bh, exponential of bh minus 1 raised to the power this alpha, raised to the power alpha. Now we know the Taylor's expansion for exponential of x. We know exponential of x equal to 1 plus x square and so on. So using this expansion, for the first term we can get 1 plus bh whole square divided by 2 and so on, minus 1 raised to the power alpha. So this plus 1 minus 1 cancel out. So we have exponent here. So if we expand this, the first term would be b to the alpha times h to the alpha, but if we multiply by this h to the alpha, so the first term would be only b to the alpha. Now if we plug the limit h tends to 0 for this term, except the first term, all the terms would be 0. So we get this equal to exponential of bt times b to the alpha. So this is the alpha order derivative of exponential of bt, which is equal to exponential of bt times b to the alpha. Now let's find the alpha order derivative of trig functions sine and cosine. So we use the Euler's formula. The Euler's formula is given by exponential of it, which is equal to cosine t plus I sine t. Then if we take the alpha order derivative of this exponential function, exponential of it, we simply use this result from the previous example. So it's going to be I is constant, which is a complex number though, I to the alpha times exponential of it. And from the complex number, we know I to the alpha can be written as exponential of alpha times pi I divided by 2 times exponential of it. Now we can combine them where I is common factor. So I times t plus alpha pi over 2. Again we can use the Euler's formula. So this equal to cosine t plus alpha pi over 2 plus I sine t plus alpha pi over 2. So on the left side we have d to the alpha cosine t plus I sine t, I sine t, I sine t. Now if we equate the imaginary part and the real part, if we equate the real and imaginary part, so the alpha order derivative of cosine t, which is given by the first term cosine t plus alpha pi over 2, and the alpha order derivative of sine t equal to the coefficient of I, which is sine t plus alpha pi over 2. So these are the alpha order derivative of the trig functions sine and cosine.